And the last one is what? Is catalyst. Is what? Catalyst. Let us look at catalyst. If you look at catalyst is a substance which speed up the rate. No, don't use speed. If you use speed, it's an error. Catalyst can speed up, can also what? Reduce, can accelerate reaction, and can also what? Decelerate what? Reaction. Catalyst is a substance which alter the rate of what? Of chemical reaction. Alter, the alter means what? Change. So a substance that is what? Alter, that change the rate of reaction. Catalyst change what? The rate of reaction. You know the word change. Change can be what? Positive, and change can be what? Negative. So that's why what the change is the sweet word that we can use to define what catalyst is a substance which what alter or change the rate of chemical reaction. So when it changes the rate of chemical reaction, it may be increase it or it may be what? Reduce it. So the definition of catalyst now is what? Is a substance by definition, catalyst. Catalyst is a substance which alter the rate of chemical reaction. It is alter the rate of what? Of chemical reaction, either by what? By increase the activation energy of the reaction or lower the what? The activation energy of the reaction. So any substance that is what? Speed up or reduce the rate of chemical reaction by what? Lowering the activation energy of the reaction or reduce the activation energy of what? Of reaction is called what? Is called catalyst. And again, I said what? A substance that is alter the rate of reaction is called what? Catalyst. And the process whereby catalyst is being alter the rate of reaction, we call it what? Catalysis. What do I call it? What? Catalysis. The catalysis is the process whereby the catalyst is being alter the rate of chemical reaction. And there are two types of what? Of catalysis. Types. Types of what? Of catalysis. And there are two types of catalysis. The first one, we have homogeneous catalysis. Homogeneous what? Catalysis. The second one, we have heterogeneous catalysis. So let's treat them one after the what? The other. You need to rub this thing. Then there are two types of what? Catalyst. We have homogeneous catalysis and heterogeneous what? Catalysis. Let me write it here again. Effect of what? Of catalyst. Yes. So I said what? Number one, we have what is types of catalysis? Types of what? Catalysis. So I said there are two types. The first one, we have homogeneous catalysis. The second one, we call it what? Heterogeneous catalysis. Why is that called homogeneous? Now let's treat it one after the other. Homogeneous catalysis. The word homo means what? Same. So in homogeneous catalysis, in this kind of catalysis, the what? Reactant. We have what? Reactant product and catalyst. And what? Catalyst are they are all in the what? Are in the same phase. In homogeneous catalyst, the reactant, product, and the catalyst of that reaction, they are on the same what? They are on the same phase. Take for example, esterification reaction. Reaction between what? Ethanoic acid plus ethanol to give us what? In the presence of what is the catalyst we use here? We use conc what? Conc H2SO4 as catalyst here. In this reaction, and look at the what? The state of this ethanoic acid. The state is in what? Is in the aqueous form. This one is also what? In aqueous form. This is also in what? In aqueous what? Form. So to give us what? CH3, COO, CH3 plus H2O. So this is also in what? In aqueous. In aqueous. Look at what? For this reaction, this is what? What? Ethanoic acid. And this one is called what? Methanol. Methanol. And this one, we call it what? Methyl ethanoate. And this is what we call what? What? Water. So what do we do here now is what? Everything we add here, they are what? Reactants. And they are in aqueous state. Everything you have here is product. They are also in aqueous state. The catalyst is also in what? In aqueous state. When catalyst and the reactant and the product, they are in the same state, either in solid state or liquid state, or they must be in the same state throughout. Such reaction, we call it what? We call it homogeneous catalyst. And another example of homogeneous catalyst, we also have it in what? In contact process of reaction of SO2 plus O2 to give you what? To give us what? 2SO3. And the catalyst used here is N what? NO, gas. Here is also what? A gas, gas, gas. Everything here they are in what? In gaseous state. So this reaction is also what? Homogeneous what? Catalyst. You can see that what? This contact process here now, I'm using what? Gas, NO gas. This NO gas, you can use as a catalyst for contact process. SO2 is in the gaseous state, oxygen in the gaseous state, also in the gaseous state. So all the reactants and the products and the catalyst, they are in the same phase, which is gaseous state throughout. But assume if I now change this thing, this NO to what? Vanadium 5 watts, 5 oxide. This one is in a solid what? Solid state. So it will change what? This from homogeneous. So because of the presence of what, you can also use NO as a catalyst instead of using what? The what? 5 oxide. So this reaction is what? Is homogeneous. So the next one is heterogeneous. For heterogeneous what? Catalyst. Heterogeneous what? Catalyst. Yeah. In heterogeneous, The product, reactant product and catalyst, the three of them, they are in what? In different phase. In heterogeneous, the reactant, product, and catalyst, they are in what? A different phase. They are not in the what? In the same phase. Take for example, look at what? Haber process. The Haber what? Process, which is the reaction of what? Haber process, industrial preparation of what? Of ammonia. We have 1 mole of nitrogen gas reacts with 3 mole of hydrogen gas to give us what? 2 mole of what? Of ammonia gas. Look at this reaction. The state of this reaction is what? Gas, gas, gas. The catalyst used here is what? Is iron. And this iron is in the what? Solid state. So the reactant are in the gaseous state, both are in the gaseous state, but this iron is solid state. So this reaction, they are not in what? In the same phase. Therefore, is what? Is hetero what? Heterogeneous what? Catalyst. Or if I use contact process again, yeah, with contact, that's what? Process of SO2 plus O2, 2SO3. Now use what? Vanadium 5 oxide here as catalyst. The state of what? Of matter for this is gas. Here we have what? Solid. Here we have what? Gas. Gas is also what? This one is what? Hetero what? Heterogeneous. And a reaction of what? Thermal decomposition of KClO3. Yes, in the presence of what? Manganese 2 what? Oxide. So give us what? KCl plus 3 mole of hydrogen gas. 2 more here, 2 more here. Look at this reaction too. This place is solid. Here is also what? Solid. Here is what? Is a gas. Here is a what? Is a solid. Can you see it now? This reaction is also what? Heterogeneous. They may give you reaction like this, and which of the reaction below is what? Is heterogeneous, which one is what? Is homogeneous. For you to know the homogeneous and heterogeneous, this is what the logic between them. In homogeneous, everything must be in the same phase. Heterogeneous must be in what? A different what? Different phase. And we can also have another example. The hydrogenation of unsaturated what? Hydrocarbon. If we hydrogenate ethene, unsaturated hydrocarbon, this is what? Ethene. We call it what? Ethene. This ethene add what? Hydrogen to it in the presence of nickel as catalyst to give us what? C what? H4, which is what? Methane. So this reaction is also what? Heterogeneous. The catalyst used here is nickel, Ni. This one is gas, this one is also gas. If we hydrogenate what? Ethene, unsaturated, to give us what? Ethane. And the catalyst we have here is what? Is nickel, and the nickel is in the what? In a solid state. So this we can also write it in this form. This is condensed reaction. We can also write it in this form as what? C what? C2. So that is what? C2 H what? H4 plus hydrogen to give you what? C2H6. So this is the condensed formula. So here we have what? Is the same thing with the one above. We have nickel in solid state, in gas, gaseous state, and hydrogenation of what? Of oil. If we hydrogenate what? Oil, Add hydrogen to what? Hydrogenation of what? Of oil. Let me, we have what? Oil plus hydro what? Hydrogen in the presence of nickel to give us what? Margarine. What? Margarine. So, and we use what? Nickel as what? As catalyst here. This one is gas. This one is liquid state. This one is what? Solid. This one is also what? Solid state. So all these reactions, they are heterogeneous what? Catalyst. So the next thing that we need to what? To treat under catalyst now is what? Types of what? Of catalyst. The one we treated before here is type of catalysis. Catalysis is a process whereby catalyst is being changed. The reaction is catalysis. But catalyst himself is a substance which change the what? The reaction. And the type of catalyst here can be grouped into what? Into two parts. We have what we call what? Organic catalyst. Organic what? Catalyst. And the second one, we have what we call what? Inorganic what? Catalyst. So the organic catalyst is a catalyst which can be found inside the what? A living organism. And these organic catalysts, they are also called what? Enzyme. They are what? Digestive what? And what? Enzyme. Organic catalysts are what? They are biological catalysts which speed up the rate of what? Of metabolic reaction in living organism. Come there. But inorganic catalysts also divided into what? Into two parts. This inorganic catalyst, we have two types of inorganic catalysts. The first one, we have what we call positive catalyst. And the second one, we have negative what? Catalyst. So the positive catalyst, they are catalysts which speed up the rate of chemical reaction. Positive catalysts are what? A catalyst. Let me treat it a positive catalyst. They are what? Positive. We have one what? Positive what? Catalyst. So these are the catalysts that speed up the rate of catalyst reaction by lower the activation energy of the reaction. Let me look at it here. Catalyst, positive catalyst, positive catalyst. Speed up is a catalyst. Speed what? The speed up the what? The rate of chemical reaction by lower the activation energy. An example of positive catalyst, they are all these catalysts here. Example, e.g., we have iron in herbal process, vanadium 5 oxide, vanadium 5 oxide, we have manganate 2, we have nickel in hydrogenation of what? Of oil, we have cork H2SO4, cork what? H2SO4. So all these are what? Are positive what? Catalysts. But I said positive catalyst is a catalyst which speeds up the rate of chemical reaction by lowering the what activation energy. Let me show the what the activation energy pathway for positive catalyst. So take for instance now, look at this pathway. This is what energy in joule. This side, this place, let me call it what? No, this side is a reaction. Let me make it big. Is a reaction part what? Pathway. This place is what? Is energy measured in joule. Hmm. Look at this reaction now. If assume this is a what? The reaction started from here, reactant, and it is what? Is move up, get to this point, yes, is move up, get to this point, and come down like this. See, look at this side. This place is what we call what? What? Product. Here is what we call what? Reactants. So the point where the reactant starts here, we call it what? HR, energy level of the reactant. And this place, to this side, we call it what? Energy level of what? Of product. And don't forget this particular point here. When the reaction stops to go up and come down, we call it what? Activation complex. Activation what? Complex. Good. I said this place is what? Reactant. Yes. But look at what? The energy difference here. Don't worry. You will get this graph better in thermochemistry. Yes. So the energy difference between the reactant and the product is known as what? H. This is enthalpy. But the difference between, let me increase this side. So, let me move it. This is energy in joule. So, yes, now, let me check this like this. Up to this side is energy of what? Activation what? Complex. Good. But difference between the activation complex here and the reactant here, we can call it what? This difference between this and the reactant, we can call it what? The difference we have there, we can call it, let me call it what? HPA, activation energy. But this is the graph of normal reaction. But if catalyst is what? Is being added to the what? To the graph. Assume I add what? Catalyst to the graph. So the reaction, the pathway for the reaction will be what? Will be come down. It will not move like this, like this, like this. Can you see it? With this black what? Black pen. So this black pen, it represents the what? The activation energy, the what? On cata, hey, sorry, we call it what? Catalytic what? Path what? Pathway. When catalyst is being added, This is what? The new pathway given. But this one we have here is on what? On kata what? Lytic what? Path what? Pathway. So if you add the addition hierarchy to it, it will reduce the what? The pathway, and the is when it is the pathway, here, this place, yes, it will be the what? The energy for activation of energy complex for catalyst pathway, HCC. But this one, if for normal reaction, is this. If you add catalyst, the reaction will speed. As a result, the pathway will what? Will drop. And therefore here, you now look at what? Distance between this activation energy complex for energy complex for catalyzed pathway and reactant, this distance here, this is, we call it what? Activation energy for catalyzed reaction. For me to make it clear, please, what I said, when poison catalyst is added to a reaction, it lower the activation energy. See it now. For this reaction now, here, let me call this place 2. Reactant, product is what? Is 6. Activation energy here for this one is what? Is 10. Another complex. Here is what? Is 8. So for this reaction now, let us find the what? Calculate the activation energy. This ER with red. EA is activation energy for what? On a reaction without catalyst. It will be what? It will be energy C, yeah, minus from here to what? Here, energy R. So yeah, what will be the what? Activation energy for reaction without catalyst is HC here is 10. We have 10 joule minus HR is what? Is 2. Final answer here is what? Is 8 joule. That is activation energy for a reaction without catalyst is what? 8 joule. So if you now add catalyst to it, it will give us what? The new pathway, which is this black. And the energy complex here, energy complex here is what? Is 8. So this is the reactant 2. This is the new activation energy given when catalyst is added to it. You are now have what? Let us find this black activation energy. Activation energy for black is the one with catalyst. Oh yeah, what is the highest here? Where is turn back? Is 8. That will be what? HCC, activation complex for catalyst minus energy level of the reactant. So you now have what? Activation energy for catalyst will be what? Here, HCC is 8 minus what? Minus 2. It will give us what? 6 joule. You can now see that what? When catalyst is being added to the reaction, the activation energy is what? Is reduced. And sometimes we can call what? Positive catalyst what? Promoter. For what? Promoter. They promote the reaction. Or some textbook agree that what? The promoter, they are not a catalyst. They are a substance that increase the efficiency of what? Of positive catalyst. So that is what? This. The next one is what? Positive, negative catalyst. If you are talking of negative catalyst, negative catalyst is a substance which reduce or slow or stop the rate of chemical reaction by increase the activation energy of the reactant of the reaction. Any substance that reduce or slow or stop the reaction to what? To commence or to occur are called negative catalyst. And the negative catalyst, they are also called what? We can also call them what? Inhibitor. So the common example of this inhibitor, we have what? H3 PO what? PO4 is an inhibitor in decomposition of what? Of hydrogen peroxide. So we can use what? This man to what? To we can use him as inhibitor in decomposition of what? Of hydrogen what? Peroxide. Here we have what? Hydrogen peroxide is what? This it can decompose to what? H2O plus oxygen gas. Who's two here? Is it balance? Two. So if we, this hydrogen peroxide, if we don't want it to want to decompose, they will now use what? H what? H3 PO4 as what? As negative catalyst. It will stop the reaction to what? To decompose to the water and what? And the formation of what? Of oxygen. So that is all about what? Inorganic what? Catalyst. But the organic catalysts here, they are biological enzymes which speed up the rate of what? Of chemical or rate of what? Of metabolic activities in what? In living cell. And the common example of organic catalysts we have what? Digestive enzyme, which is what? The enzyme that is acted on what? On the food we eat. And a common example of what? Digestive enzyme, we have what? Enzyme ptyalin in what? In salivary gland of what? Of our mouth, which acted on what? On the cooked starch and convert them to what? To the maltose. So when the food is what? It being swallowed and it contains protein, when it gets to the stomach, there is a particular enzyme inside the stomach called enzyme pepsin. The pepsin is acted on what? On the protein. So when it is what? The food is what? Is escaped the what? The stomach and move to the duodenum, in the what? Which is what? The first part of the what? Of the small intestine. And inside the what? The small what? Small intestine, if the food is what? Is contain what? Fat and oil, which is what? Lipid. And they will now have what? Another enzyme there, which is called enzyme lipase. So the lipase is an enzyme that is acted on what? Lipase is acted on what? On lipid. So, and we have enzyme what? Ptyalin in the mouth, which is acted on what? On starch, cooked starch. We have enzyme what? Pepsin. This one is acted on what? On what? Protein. And others, we have enzyme erythrin in a succus entericus of the stomach. We have amylase, sucrase, and others. So all these ones, they are what? They are biological enzymes. That is all about the what? The reaction kinetics, which is what? Factors that affect the rate of chemical reaction. So the last aspect of this topic is what? The mathematical proving of orders of reaction.